Okay, I hope everybody is fine. In this lecture, we want to learn how to solve a triangle. What is the meaning of solving a triangle? What does that mean when they say solve a triangle? We have learned about solving an equation in the past. It means finding the unknown in the equation. But solving a triangle means finding all three sides and all three angles in a given triangle. Usually, there's six elements involved: three sides, three angles. 3 plus 3, 6. Out of six elements, usually they give you three of these elements. Maybe two sides, one angle, maybe two angles, one side, maybe all three sides. It could be different scenarios. And you have to find the other three elements, okay? And the moment you find everything, the moment you know that all three sides, all three angles of a triangle are equal to what, then in that case you can claim that the triangle is solved. In this example, we have a right angle triangle, and side A is given to be 24 units, and hypotenuse C is given to be 35. But side B is unknown, we don't know. Angle A and B, we don't know what they are, but we know that angle C is 90 degrees. That's the right angle. So out of six elements I mentioned, three of them are given, two sides, one angle are given, and what is unknown here is two angles, one side. If I find those two angles and one unknown side B, then I can claim that I know all three sides, all three angles of this triangle, and therefore the right angle triangle is actually solved. I can claim that I solved the triangle. In order to do this, there's different ways of doing it, but the tools we have is very simple. One tool is SOHCAHTOA, the other one is Pythagorean theorem. So what I'm going to do, I'm going to look at the given information, and I'm going to say when two sides out of three are given, the third one can be found using Pythagorean theorem. So I'm going to say a squared plus b squared equals c squared. That's Pythagorean theorem. And a is 24. So I substitute B, I don't know, and C is actually 35 squared. 35 squared is 1,225. 24 squared, we can use a calculator to see how much that is. And it is 576. So 576, we are going to subtract it from 1,225. And this way, we can find the value of B. So 1225 minus 576, 649 is the answer. And we take the square root of both sides. And sure enough, we have to put the plus minus. But the minus sign would be inadmissible because we're talking about a distance. We're talking about the length of a side. How could length be negative? So the negative answer would become inadmissible automatically. So B would be square root of 649. Now, what is the square root of 649? Again, that can be calculated using the calculator. The answer would be 25.5. 25.5. So roughly 25.5 units. So this is side B. So immediately when I find one of the unknowns, I include in my chart. This is a very nice method, an organized way of solving the problem. It's a chart method. You construct a chart, you put down what is given, what is required, so that you can keep track of sides and angles that have been found and sides and angles that yet need to be found, So side B is 25.5. I just got it before I forget. I'm going to add it here, 25.5. So right now, I see that I have all the sides, so I keep track of sides and angles, and I know that still I have to find two other angles. So it's a good way of keeping the track of what is found, what is yet to be found. Okay, now I'm going to go after angle A, perhaps. So I'm going to say, to find angle A, I can use sine ratio. I can say sine of angle A is the ratio of opposite, which is BC, or we can say lowercase a, over hypotenuse AB, which is C. So sine ratio is opposite over hypotenuse. And both are given. When something is given, it can go wrong. So I'm going to go sine of angle A is 24 divided by 35. And to find angle A itself, we are taking the inverse sine of 24 over 35. So we just need a calculator. Inverse sine, we use the shift key on the calculator. 24 divided by 35, and that is 43.3. So 43.3 degrees. You can round to the nearest degree. Oftentimes it's a good accuracy. So I can say roughly the answer is 43 degrees. Okay. And immediately before I forget, I'm going to add it to my list. I say 43 degrees. I include it in my chart, and I still keep track of the angles and sides. I know that I still have to find angle B. So it's a good way of, looking at the whole picture basically. Now I use the sine ratio, but some of you might say, why did we not use a tangent ratio or cosine ratio? And this is a valid question. We could have, and we're not saying no. But the reason why I used sine was because sine involves opposite and hypotenuse, and both those values, opposite side and hypotenuse, were given to me. And when something is given in the question, that is not wrong. But if I would use, let's say I would use cosine, okay? So if I would use cosine, I would say cosine is adjacent or hypotenuse. I would say B over C, and then I would use 25.5, which is what I got. And then C is the hypotenuse 35, okay? And nothing is wrong, mind you. Angle A would be inverse cosine of this figure. And in fact, if you try it with the calculator, you would get the same answer. And I'm not saying no. But the thing is that, God forbid, if you make a mistake in finding the value of B, and let's say instead of getting the correct answer of 25.5, let's say you get some weird answer like 52 or something, okay? And if that is 52, you're using 52 as a wrong answer to find another wrong answer, right? So that's why, to be safe side, it's better to use the values that are given in the problem because there is no error involved in them. I'm not saying that there was an error involved here either, because 25.5 was the perfect right answer. But what if we would make a mistake here and we would grab this wrong answer, plug it in the formula, and find another wrong answer? So that's a lose-lose situation. So it would be better to use 24 and 35 that are given values. This has nothing to do with math. This is just pure logic. But if you have 100% confidence in your solution, in your answer, as I did, as I had, so you can get exactly the same answer, no questions asked. I could even use tangent ratio here to tell you the truth. I could say tangent of A is opposite over adjacent, 25 divided by 25.5. Take the inverse tan, you would get exactly the same answer. So there's different ways of getting the answer. To find angle B, I'm not going to use trig ratios. I'm going to use the easiest way of doing it. So I'm going to say angle B is equal to 180, take away 90, take away 43 degrees. Why am I saying this? Because we know that the sum of the interior angles in any triangle is 180 degrees. So if you already know that one angle is 90 degrees because it's a right angle triangle and the other one is 43, so by a simple subtraction, you get 47 degrees for the measure of the remaining third angle. So that is 47 degrees. So I found the last remaining angle, 47 degrees. So two unknown angles, angle A and B, were found. The unknown side B was found, 25.5 units. And we can claim at this moment that this triangle is completely solved because we know all three sides and all three angles. So from now on, when they say solve such and such triangle, it means finding all three sides and all three angles. And in order to achieve this, there's different ways of doing it. You can use sine ratio, you can use cosine ratio, you may use Pythagorean theorem or may not. So different ways of doing it, and all of them are valid and correct. Okay, so I hope you will be practicing as much as you can. Okay, take care.